What's up, pre-calculus students? Mr. Messner here. Let's review. Let's get ready for our test. We can take logs, write as exponents. We can take exponents, write them as logs. I like to do the inverse property. Logs and exponents are inverses, so 3 to a power will undo a log base 3. I get 1/9 equals 3 to the negative second. That's fine, just leave it like that. You don't see a base, assume there's a base 10. To undo log base 10, you take 10 to the power. 1 equals 10 to the 0, that's correct. You want to write in a log form, it's like, how do we undo the exponent? Well, we invented logs to undo exponents. So I would take the log base 5 to undo the 5 to the power. It just gets the power 2. And then I take the log base 5 on the right side to get log base 5 of 25. Same here, natural log of both sides. E to a power is log base E. Natural log is the same as log base E. That's a good review. Log is the same as log base 10. That's a good review too. So I get 7 equals the natural log of 1097. It's not equal to, it's approximately. Now, many years, okay, not this year, pandemic year, where we know that you could be using a calculator and we can't tell. Many years you'd be asked to do this by hand. Okay, moving forward, you need to be able to do things by hand. If you get to calculus, you'll like next year when we're back in school, you'll have to do things by hand. But like, I can't stop you from plugging these into your calculator and get the answers right away. Okay, but let's just pretend we can't. All right, let's get the answers. I like to write this as equal to a value and rewrite it as an exponent. So 2 to the log base 2 of 64 is just 64. 64 equals 2 to what power? Okay, 2, 4, 8, 2, 4, 8, 16, 32, 64, 6. So this is 6. And then after you've done a couple of these, you realize it's like, okay, this to what power is this? Is really the question. And let me show you this. I would take 5 to the power, 5 to the power. You see 1 equals 5 to the x. 5 to what power gives me 1, 0. This is a property of logarithms. The log of any base of 1 is always 0. Different ways to do this. You can either think like 2 to what power is 1/4, or we could try to rewrite what's inside here so that it's 2 to a power. That way the log base 2 of 2 to the power cancels out. I'm going to do that. So I know I can write 1/4 as 1 over 2 squared. And I know if I have this power in a denominator, I can move it as long as I flip the sign of the power. So I got 2 to the negative second. So the answer here is -2 because log base 2 of 2 will cancel, just gives me the negative second. Or 2 to the negative second power gives me a 4th. Natural log is log base E. That'll undo the E to the power and just leave the power. That one's easy enough to do. It's the same thing here. Before though, I tried to simplify things. I'm not going to say this is equal to like I don't know, 1 over the square root of something. I don't know. I'm going to rewrite it. This is a 1/2 power. That's important to know. The square root is just a 1/2 power. So this is 1 over e to the 1/2. I could rewrite this as e to the negative 1/2 in the numerator, which means the natural log and the e will cancel each other out, just give me -1/2. It's the same thing here. It's log base 16 of 16 to the 1/3. So this is just 1/3. Okay, let me just write that down. It is in the form that is good. It's going to undo each other. Log base 16 of 16 to a power. So boom, you just have the power. 2 to what power is 32? 2, 4, 8, 16, 32. That's 5. 4 to what power is 8? I don't know that one. It's not 2. Let's see what I can do here. This is tricky if you were going to do it without a calculator. I'm going to use change of bases. I'll show you why. I know 8 is 2 cubed. So I got log base 4 of 2 cubed. But I still can't simplify this unless it's log base 2. So I'm going to change bases and rewrite this as log base 2. Now, watch this. The numerator is 2 cubed, log base 2 of 2 cubed. The denominator is log base 2 of 2 squared. So this ends up being log base 4 of, the log base 2's cancel, the log base 2's cancel, 3 over 2. So this is actually 2 to the 3 over 2 power. The answer is 3 over 2. That's gone. That's gone. 3 over 2. That's how you do that without a calculator. Obviously, you plug those into your calculator this year, unfortunately. Expand the logarithm. Remember some logarithm rules with expansion and contraction. Logs work like exponents. So some rules, we'll just write them down here. Similar to, this rule, x to the 2 plus 3, you can write it as x squared times x cubed. Similar to that, probably actually easier if you do it the other way. If you have a product with exponents, like x to a power, you can add those things together. So that's 2 plus 3. I don't want to write it as 5. I'll write it as 2 plus 3. Same with logs. If you have log, say, a of b and times c, or 2 times 3, you'd have the log of a of 2 plus the log of a of 3. It's a whole 2 plus 3 kind of thing with exponents and logs. So the first thing I'm going to do is separate these two things being multiplied together. It's log base 9 of q to the 0.6 plus log base 9 of, that's a 9, not a g, of r to the 0.4. Another property we're going to be using is the power to a power property. If you have a power to a power, you multiply the powers. This is x squared 3 times. This is x to the 6, x to the 2 times 3. Well, with logs, if I have log base a of b to the c, power to a power, we can end up multiplying the powers. Now the c ends up coming in front of the log. Maybe I make this like 2 and 3 just so you're comfortable with it. I know you guys hate letters. If you could use numbers, it might be better. So I can bring this 0.6 and this 0.4 down. 0.6 log base 9. Ooh, logs and 9s are tough. Q plus 0.4 log base 9 of r. And then the last property is the division property. It's subtraction. It's kind of like a combination of this. If this was like a negative first power, then you'd bring it down. It's kind of like when we have x to the 5th over x squared. It's the same as x to the 5 minus 2. So that's what happens here. If you have log base a of 5 over 2, it's the same as log base a of 5 minus the log base a of 2. So to expand this, I have log base 9. It's tough to do the g than the 9. Of r cubed minus log base 9 of q to the 6th. Bring down the 3, bring down the 6. 3 log base 9 of r minus 6 log base 9 of q. Oh man, that's tough to write down for me. I'm a lefty, and my penmanship's horrible, as you probably can tell. So going the other way around, condensing, adding, as long as the logs are the same, you can then multiply what's inside of them. Do they want me to write this as x to the negative third and then negative 3? I don't think so. I think we want everything inside the logarithm. But this and this and this and this are all the same. I'm probably going to stop here. This is a good question. Like, these are the questions that are the most common. Is like 3 log 6 minus 2 log 3 is equal to the log of what number? Well, it'd be the log of 6 cubed over 3 squared. 6 cubed, 6, 36. What's 36 times 6? 216. So the natural log of 216 over 9 is the same as 3 log 6 minus 2 log 3. Don't believe me? I'll show you. 3 natural log of 6 minus 2 natural log of 3. 3.178. That is the same as the natural log of 216 over 9. Okay. Is 216 over 9 something? Ha! That's funny. I'm better than that, actually. Yeah, I'm better than that. Watch, ready? I'm much better than that. I'll show you. This is math magic. 6 is 2 times 3. So I'm going to rewrite that. Ready? 2 times 3 cubed is the same as 2 cubed, 3 cubed. Well, I can cancel 2 of these 3's with these 2 of these 3's, giving me natural log of 2 cubed times 3. That's 8 times 3, which is 24. That's one way to simplify. Obviously, you guys are soft and use your calculators. So do I sometimes. All right, let's solve some equations. We got numbers to exponents. We want to solve for the x and the exponent. How do we do it? This one's a nice, easy one. I'd start by taking the log base 1/3. Now, I can find what the log base 1/3 of 81 is. And I could have written this as 3 to the negative first and make like these negatives, but I don't want to complicate things if I don't have to. You ask for an exact solution. As long as it's an exact solution, this is fine. This would be acceptable. Like 3, 9, 27, 81. That's 3 to the 4th power. Watch what I can do here. 3 to the 4th. That turns into 1/3 to the negative 4th. You're not going to do this. You're going to just type this into your calculator. 1/3 to the negative 4th is the same as 3 to the 4th. So that's negative 4 plus 2. It's negative 2. Okay. If you just type this into your calculator, it'll be fine. All right, these are the fun ones, right? Oh, look at this guy over here. What are we doing over here? I think we'll be fine, actually. Change everything into 2's. That's not that bad. This one's not that bad either, actually. I can change it. Instead of doing like the log of both sides and natural log of both sides like we've done before, there's another technique to doing this one. Because I know 8 is 2 cubed. So I got 2 cubed to the x. And I got 4 is 2 squared. 2 squared to the x squared minus 3. Power to a power, multiply. This is 2 to the 3x. This is 2 to the 2x squared minus 6. I'm going to show you multiple ways to do this problem. But this is the easiest one. The other one is going to be horrible, actually, if you try to take the log of both sides. Because you have squares and x's. We haven't seen a problem like this yet. This is a little bit advanced. If you're going to see this on this test, I mean, it'll be tough, but that's okay. We're getting ready for it. So I subtract the 3x because I got x squareds and x's. You have to look to factor. Are there two numbers that multiply to get negative 12 and add to get negative 3? 4 and 3 aren't it? 6 and 2 aren't that. I'm making sure I did everything correctly. I think we have to use the quadratic formula for this. Gross. All right, let's see if it works actually. I haven't done this. The opposite of b plus or minus. I'm gonna just do the plus. Square root of b squared minus 4 times a times c all over 2a. Let's see, 8 to that power. Does that equal 4 to that power squared minus 3? Big money, no waves, no waves, no waves. Stop! Oh, goodness. You guys remember the quadratic formula? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you took Algebra 1 with me, you would have learned that song. All right, so those are our two solutions. This one's the same way, where it's actually beneficial to rewrite it as 2 to a power. This is 2 to the x times 2 cubed to the negative x. This is 2 squared to the x. We haven't seen these. These are tricky. This is 2 to the negative 3x to the 2x. Okay, I got a bunch of 2 to powers, but like I should simplify this. Like just like x squared times x cubed is x to the 2 plus 3. You can add those things together. 2 to the x times 2 to the negative 3x. You can add those powers together. I get 2 to the negative 2x. Equals 2 to the 2x. If I take the log base 2 of both sides, I get negative 2x equals 2x. And like the answer is 0. I mean, how do you see that it's 0? It's like you subtract 2x, you get negative 4x equals 0, x equals 0. I can't believe that problem, actually, if that's what we're looking for. Oh, man. But if that's it, that's it. That's good. I'm graphing both of them and see if they intersect. Yeah, just at 0. That's a good question. All right. I'm going to say this. Like this one and this one, I would say like, don't stress about these two. We haven't seen this yet. This one you should be able to do. This one. These are better. 10 to the power, take the log base 10 of both sides. That's log base 10 or just log. So you cancel that, you get 2x equals log 57 divided by 2. You ready for that answer? You can type that into your calculator. I'm not going to do that. 2 times 10 to the r minus 1. You can't multiply the 2 in this 10. It's in the clutches of that exponent. So what you do is you divide. This is like 2x equals 39, right? You don't try to just like keep this over here or something. Divide by the 2. I get 10 to the r minus 1 equals 39 halves. I'll take the log base 10 of both sides. That's just the log. Get r minus 1 equals log 39 over 2. I add 1. Going to subtract 3. Divide by 4 first to isolate the e to the power. So subtracting 3, I get 42. Dividing by 4 is 12. What? No, divide by 2, that's 21 halves. Remember, 42 fourths, 21 halves. Natural log both sides. N plus 2 equals the natural log of 21 over 2. Subtract 2. And this is the type of answer that you need to get. You're asked for an exact answer. That means decimals don't work. So use every single step and solve. I took the natural log of both sides here. Exact solutions again. Divide by 2 to isolate the log in this case. And now we're going to have to undo the log. You undo logs with exponents. This is log base e. Take e to the power. 4x equals e to the 15 halves. Divide by 4. E to the 15 halves over 4. The log is isolated. I'm ready to take e to the power of both sides. Absolute x plus 1, not absolute, square root. Silly. Equals e squared. Solve. I'm going to square again. You had a quiz question kind of like this where you needed to make sure you knew e squared squared is e to the 4th. It's not because you're adding them, it's because you're multiplying them. Be careful. And then we subtract 1. Didn't see much like this in a while. A lot of us may think, oh, log base 8, log base 8, log base 8, 8 to the power on everything. No, you can't do that. You can't do that because of the subtraction. If you do 8 to the power of both sides, it's not just x minus 2 minus x plus 2. That's not right. You have to combine things. So it's just 1 log base 8. Example, like if I have 2 plus 3 and I take 2 to the power of 2 plus 3, is that going to be 2 squared plus 2 cubed? This is 4 plus 8, which is 12. Okay, well, 12 is not the same as 2 to the 5th. 2, 4, 8, 16, 32. So you can't just take 8 to the power and say x minus 2 minus x plus 2. This kind of shows you, no, you cannot do that. So instead, use log properties. 8 to a power. Now we can get stuff. I get x minus 1 equals x minus 2 over x plus 2. Great question. Move everything onto the top level. Multiply the tops by x plus 2, which is the denominator here. Now, how do I solve this? You're going to have to distribute this. You get x squared plus x minus 2 equals x minus 2. You got x's and numbers. Is this going to be 0 again? Subtract x, add 2, get x squared equals 0. Yeah, but I can't have 0 because that's negative 1. I'm going to go ahead and say there's no solutions. Let me see if that's true. X minus 1 over equals to x minus 2. Yeah, just 0. But it won't work in the original one. All right. Remember these? A lot of people think that it's like, oh, looking for x squared plus 3x minus 2 and factor that. No, it's not the case. Okay. If 3 to the x was something like y, this would be y squared plus y minus 2. You're looking for two numbers that add to get 1 and multiply to get negative 2. Positive 2, negative 1. So it would be y plus 2, y minus 1, but I replaced 3 to the x with y, so it's really 3 to the x plus 2. 3 to the x minus 1. Solve these two equations, set equal to 0. You get 3 to the x equals negative 2. Take the log base 3 of both sides, you get x equals log base 3 of negative 2. Can't do that. You can't take the log of a negative number. A number to a power is always positive. A positive number to any power is always positive. 3 to the x minus 1 equals 0. It's another answer of 0. Good stuff. Log base 3 of both sides. Log base 3 of 1, 0. 3 to 0 is 1, plus 3 to 0, which is 1. 1 plus 1 is 2. 2 minus 2 is 0. There's your answer. 0. Okay, same thing here. This is y squared plus... What is going on here? Hold on a second. This is different. Okay. Wait a second. This is 3 to the x times 3 to the first. Oh, yes. Oh, man. So, like, we usually use, and you do this in calculus, actually. We usually use this property, and we go this way, 2 plus 3, right? X squared times x cubed is x to the fifth. Well, sometimes it's beneficial if we go the other way. If I have a sum, I can write it as a product, a sum of powers. I can write it as a product of the base to the individual powers, right? I'm going x to the 2 plus 3 equals x squared times x cubed. 3 to the x plus 1 is 3 to the first times 3 to the x. It's just like, you add those two things together to combine them. I'm separating. This is minus 4 equals 0. So now look at this. If 3 to the x is y, I have y squared plus 3y minus 4. I do have a number now. This is a good one. The two numbers that add to get 3 and multiply to get negative 4 are positive 4 and negative 1. So this would be y minus 4y plus 1. Sorry, other way around. Replace y with 3 to the x. 3 to the x plus 4. 3 to the x minus 1 equals 0. Solve, subtract 4, you'd get x equals log base 3 of negative 4 here. That'd be wrong. Add 1. Look, it's 0 again. 3 to the 0 plus 3 to the first is 1 plus 3 minus 4. Math humor. 3 to the x equals 1. Take the log base 3 on both sides. X equals the log base 3 of 1. Log base 3 of 1 is just 0. All right. I told my students in class, to do a problem like this. Sometimes, if you want to, turn things into decimals. And I think that helps some of the students. Take the natural log of both sides. You can take the log base 4 of both sides. I'm going to take the log base 4 of both sides. Because if I take the log base 4 of both sides, I get x equals the log base 4 of 3 to the 1 minus 2x. Now, the reason why I do this, and this is especially helpful if you're intimidated by this log base 4 of 3, is that you can turn this into a decimal. Okay? Write it as a decimal. And then treat it as a number. Like a lot of times you don't think of log base 4 of 3 as being a number, but it's a number. I have to pause. Actually, I'm good. I'm going to let you guys start your test now.
What did you say?
What?
You were saying that before, something decimal?
Yeah, log base 4 of 3 is a decimal. This is pre-calculus stuff. I hope you're not panicking. Okay, ready? Set. Some of you are good. More of you are good. Everybody else, get going. This is for my class. All right. You can do the log base 4 of 3, and that's a number. If you are not comfortable with keeping log base 4 of 3, turn it into 0.792. And it's like, okay, if this was 0.792, what would you do with it? Okay, well, distribute it. So you get 0.792 times the 1. This is the 0.792 minus 2 times that number. I mean, minus 2x. So like 0.792 times that negative 2 number, like take that number, multiply by negative 2. You know, are you more comfortable with this? Maybe. You get 0.792 minus 1.58 number. And now I'm putting dots after that, knowing that I'm not rounding or truncating or anything. And that's times x equals x. Well, I'm going to add the 1.584 x's to both sides. And then I got 0.792 equals what ends up being 2.584 x's, because this is 1x plus that many x's. And then you can divide. So this should be a negative number. I mean, like, I'm going to take that, add 1 to it. I get that. 0.79, the 0.79
Mr.
number.
Lister, are you talking to us?
Divided by the 2.58 number. That's your answer. Okay? Guaranteed. This is a way that I showed students who are just like not comfortable with not having numbers. Okay, so 0.306. I'll show you the other way to get it, which is keeping like the logs where they were. So I got log base 4 of 3. I would distribute it. Get log base 4 of 3 minus 2 times the log base 4 of 3 times x equals x. I would add the x to both sides. Log base 4 of 3 equals x plus 2 log base 4 of 3x. Factor out the x. This is essentially what we were just doing. But sometimes if you don't use numbers, you kids freak out. And I get the solution, log base 4 of 3 over 1 plus 2 log base 4 of 3. And I'll show you how it's going to be the same number. Log base 4 of 3 over 1 plus 2 log base 4 of 3. Same number. Okay. You could also take the natural log both sides, the log of both sides, like this. This is fun. Tough to use numbers here. E to the x plus 3 equals pi to the x. It's a great question, actually. We're going to take the natural log of both sides, because if I take the natural log of both sides, this just gives me x plus 3 equals x times the natural log of pi. Now, I'm going to subtract x from both sides to get them all onto one side. Factor out an x, divide, and you get the solution for x. This can be done with decimals. You can do natural log of pi and get a number. And if you like numbers instead of this, I mean, for now, you'll be fine. Like maybe moving forward in the future. When in calculus, you don't get to use your calculator all the time. You have to like actually solve stuff fully. And you shouldn't be using your calculator for this test either. Look at that, 20.728. Is that really right? Let's see, e to the this number plus 3. Is that the same as pi to the this number? Yeah, it's awesome. Can't take 10 to the power yet. This needs to turn into an x squared. Now I can take 10 to the power. 7x minus 12 equals x squared. It's quadratic. Move everything onto one side, solve by factoring. Or the quadratic formula. Or giving up. -4, -3 are the two numbers. Two solutions, 4 and 3. Make sure they both work. 4 times 7 bigger than 12. 7 times 3 bigger than 12, so that's good. All right, back to this guy. You take the log base 27. Actually, do it like you did G. Do it like you did F. Fine. I'm going to do it a little bit different because I noticed that 9 is 3 squared and 27 is 3 cubed. Which means this is 3 to the 6x equals 3 to the multiply 9x minus 12. 6x equals 9x minus 12. Solve. -3x equals -12. X is 4. Gosh, this goes on forever. Let's keep going. 10 to the power. I think I just did this problem. Yep. Just did it. Whoa. All right. For this one, I'm going to have to take 2 to the power because I can't simplify this on the right side. But watch what I can do. 2 to the left side, y plus 1. On the right side, I have 2 to the. This is another example of you got this. Sometimes it's beneficial to rewrite it like this. I can rewrite this as 2 cubed times, not plus, times 2 to the log base 2 of y minus 6. That's y minus 6. So that's y plus 1 equals 8 times y minus 6. Y plus 1 equals 8y minus, my goodness, 48. 6 times 8, 48. I haven't done that in a while. Subtract a y, I get 7y. Add 48, I get 49. 7 times 7. 49. My mind is going right now. Yeah, cool. 7. 7 log base 2 of 8 is 3. This is 1, 3. Yep. All right. Log, that's 10. You can do 10 to a power. 3x plus 1 equals 100, which is 10 squared. Subtract 1, divide by 3. That's nice. Whoa. Well, get rid of the log base 3. What do you have left? That. Get rid of the log base 5. What do you got? 125. Get rid of the 5 by dividing. E to the power. Multiply by 4, divide by 3. Log properties. You can do e to the power. Like, you've kind of done it right now a couple times in a row. Where it's like, oh, e to this plus this can turn into e to this. Well, that'd be 5x times 4x. That's not right. It's 5x times x to the 4th. So, like, don't do that. Even I was about to make a mistake there. Let's move this 4 up. Let's use log properties to combine. Shows there's like a lot of different ways to do these problems. Adding logs is the same as multiplying the stuff inside. Oof. E to the power of both sides. I get 5x to the 5th equals e to the 6th. I divide by 5 and then 5th root it. So e to the 6th over 5 to the 1/5. All right. Word problems galore. All right, so we got our rule kind of like future value equals present value times 1 plus our rate divided by the compounding to the years times the compounding. Yep. We're just talking about a yearly situation here, so I don't have to worry about a compounding, dividing, and then times. 23450 is the present value. Decreases, so it's 1 minus 0.0312%. This is the function that would model it. 2018 is 20 years later. So type that in your calculator. All right, you guys love numbers. $12,440 approximately. Number of people in a high school community who have heard a certain rumor. This is a calculus question. P is the total population, D is the number of days since the rumor began. Community of 1,000 students, that's P. How many have heard it after 3 days? 1K, 1 minus e to the negative 0.15 times 3. I'm not going to type that in the calculator. How long will it take for virtually everyone to hear the rumor? You want to solve for 0, but you won't be able to. Actually, let's see. Wait. Oh. So the question is like, when is the number of people 1,000? How many days will we meet up? I feel like I can't do this. So maybe we do 999. Let's see. If I divide, we get 1 equals 1 minus e to the negative 0.15d. That's 0 equals, can't take the natural log of 0. So I'm going to do 999 is pretty much everybody. Okay, except for one person. So I'm going to divide the 2. I use my calculator. 999 people have heard it. Okay. I then will subtract 1. Take the opposite of both sides. So I get 0.001 equals. I took the opposite of both sides. Like, all right, let me just show you. Sorry. This is a review video. Subtract 1. So I get negative 0.001 equals negative e to the negative 0.15d. Take the opposite of both sides. Okay, so now this is a positive and this is a positive. Okay, natural log both sides. Get negative 6.907 equals negative 0.15d divided by negative 0.15. 46.05 days. Cool. Couldn't do 1,000 because like I would have to take the log of 0, which I couldn't do, which is why virtually everyone will go with that. %92 per year. Okay, so my present value, 1 plus my r to the t so 16 years. Like that's the hard part. That's the difference between 2012 and 96. 96, 2006, 2016 is 20. Subtract 4, 16. Okay. 2573 times 1 is 0.92 to the 16. Type that in your calculator. Wow. 87.752 million. All right. Value of a truck starts at 52,000. It depreciates 18% per year. 3 years from now, $28,671. 30 months ago, got to turn into years. $30 months in the past means like we're talking about a negative time. T equals 0 is like now. So like in the past, t is going to be negative. 30 months, 1 year is 12 months. 30 divided by 12. 2.5 years. So t is negative 2.5 is 30 months ago. So equals 52K. I'm going to do just 52. $85,402. All right, now we got an equation we can solve. How many years will it take for my final value to be 20,000? So we got 20 divided by 50. I got 1 minus, so it's 2/5. I'm just going to leave it as 2/5. 1 minus 0.18 is 0.82. Take the log base 0.82 of both sides. That'll undo 0.82 to the t. Use your calculator for this. $4.617. Years. Not many years. Cars depreciate in value. Houses do not depreciate in value. I mean, I'm gonna just like tell you what to do. Take 4, plug it in here. When does the model predict the percent? Okay. Okay, so this gives me the percent. Model's the percent. Okay. 50%. So that's like, when is this 50%? I assume it's gonna be 50 rather than 0.5, but let's think about this. Let's plug in 4 just to see what we get if it's like 50 or 0.5. I think we're gonna get 0.5. No, 42.66 is 42.66%. So we need to solve for 50. All right, how do we solve this equation? I'm going to bring everything up to the top. So multiply both sides by the denominator over there. Get rid of the 50. You might distribute, and if you distribute, you'll still get the same answer. But like, I don't know, if you divide by 50, it might be a little bit nicer. Subtract the 1, divide by 1.484. Gives me e to the negative 0.239t equals that. Take the natural log of both sides and then divide. So let's just do some of that work. Subtract the 1, divide by the 1.484. Oops. Natural log both sides. Divide. $6.165. This is in years. Last page. Population of Tokyo. 2018. So 02 is 10. 12 is 22. Wait. 12 is 20 years. 30, 40, 50, 60. It's plus 6. I'm not thinking, I'm like done. $26. Okay. P standing for population, not like present value. $36.601 million. When does the population double? So I got to figure out the double of 27.54. It actually doesn't matter because watch, like when you solve, and you'll just divide it, you'll get 2. But so 55.08 equals 27.54 times 1.011 to the x, divide, you get 2. Log base 1.011 of both sides. Is our answer. $63 years. You got a decay situation. It gives you the formula. How much sample is left after 20 days? I'm not going to do that. Ooh. All right, so we got to have the half-life formula. So it's 1/2 to the years over the half-life. So it's like, yeah, if I have something 5,730 years old, we'll have half of the carbon left in it. So it's like 1/2 to the first. So that works. How old is like a wooden statue that is a third? So like, let's say the statue has 1 gram to start with. So that's its present value. We're figuring out when its future value is a third. Okay. We need to take the log base 1/2 of both sides. The 1 just is gone. This is t over 5730. Multiply both sides by 5730. And there's my answer. 5730 log base 1/2 of a third. Don't type in 0.333. Type in 1/3. 9,081 years. Okay. Long video, but hopefully this helps. Hopefully some of you watch it, get something out of it. Later.